This video is part 2 of the discussion on polymorphism in drawing OpenGL graphics shapes.
In part 1, we have reviewed the basics of inheritance and polymorphism. In this video, we will discuss the use of polymorphism to draw different OpenGL graphics objects. We will implement the classes represented by this UML diagram. The parent class is GObject, and line, triangle, and rectangle are child classes. So as discussed before, line is a GObject, triangle is a GObject, and rectangle is a GObject. Each of them implements a draw function. You will see how the concept of polymorphism is applied in selecting an appropriate draw function when we draw a GObject, which could be a line, or a triangle, or a rectangle. Let's start with a basic OpenGL program. For the convenience of programming, we define an xi class to represent a point or a vector in 2 dimensions. Its implementation is very straightforward. The minus operation could calculate the difference between 2 points. We declare 3 xi variables, point 0, point 1, and point 2 that we will use later. This is a basic OpenGL program that could draw dots when we click on the mouse. Here's the main. We use double buffering so that we could move objects without causing flickering. Display, my mouse, my moved mouse, my keyboard are the callback functions. When the graphics window first appears, the display function is called. If it is called the first time, it does some initialization. We will use a white background. We set up the 2-dimensional world coordinates. X is from -10 to 10. Y is also from -10 to 10. When we draw a polygon, we only draw the outline. Each time display is called, the color buffer is cleared with red, green, blue, values 1, 1, 1, that is, a white screen. Here's the draw dot function. The first time it is called, we clear the working color buffer as we are using double buffering. We set the point size to be 9 × 9 pixels, and the color to be red. This draws the point, XY value specified in world coordinates. This is the myMouse function. When we click the left button, it captures the mouse position, specified by X0 and Y0, but they are in screen coordinates. The function mouse to world converts it to world coordinates. We call the draw dot function to draw the point and swap the back buffer to the front using glut swap buffers. The currently clicked point is point 0, and we save the 2 previously clicked points in point 1 and point 2. Let's compile and execute this program. Here's the make file. Let's compile and run the program.
So we can draw dots by clicking on the mouse button. Now, let's add a little more to this program.
We declare the parent class GObject, which is simple. For simplicity, we make everything public. The data members, position, line width, and color V are self-explained. The default line width is 3 and the drawing color is black. We can use the set function to set a new position of the object. Here, draw is a virtual function. The equal to 0 means the parent does not give any implementation of the function. It will be implemented by the children. It is referred to as a pure virtual function, like an abstract class in Java. Line is a subclass. It inherits everything from GObject. To construct a line, we specify 2 endpoints, P1 and P0, which can be defined by clicking the mouse. We calculate the difference between them and save the value in the data member D. So position and D are used to draw the line as shown here. We define a decGQ, which is a double-ended Q, in the C++ standard template library, or STL. It holds pointers to objects of GObject. We add this statement to display, which draws the object saved in GQ. We modify my keyboard. We declare a pointer G, which points to a GObject, and an iterator it, which points at an element of a queue of GObject pointers. When we press L, we construct a new line and let G point at this new line object. We push this G pointer to the back of GK and use glut_post_redisplay to call the display function, which draws all the objects whose addresses are saved in GQ. Let's compile and run the program. We specify the two endpoints by clicking the mouse and press I to construct the line.
We need to delete the old my keyboard function here. Now we can compile this revised version and we can run it. So we can draw a line by clicking 2 points and press L. Okay, now let's add more to this. So we want to add triangle and rectangle to this.
Now, let us add the triangle and rectangle classes to the program. This is the triangle class, constructed by specifying 3 points. 1 point is the position of the triangle, and data members D0 and D1 are the differences of the other 2 vertices from position. Its member function draws the triangle. The rectangle class is similarly defined. We add these statements to my keyboard function. When T is pressed, a new triangle is constructed. When R is pressed, a new rectangle is constructed. Their addresses will be saved in GQ as before. Let's compile and run the program.
So let's compile this and run it. So of course we can draw a line as before. We can draw a triangle also, or rectangle. We can draw as many as we want.
We could draw different objects properly because of the polymorphism mechanism. Here, we define a G object pointer, but it can point to a line, or a triangle, or a rectangle. The appropriate draw function is called during the runtime, depending on the child it is pointing at. Now, let's add a little more to the program. We add to GObjective function as target, which returns true if the object is the search target. Otherwise, it returns false. Another function we add is clone, which is a pure virtual function. It is implemented by the children. It duplicates the child object. The position of the duplicated object is added by an offset of 1, 1, so that it won't completely cover the original 1. We implement this function in the child classes, line, triangle, and rectangle. We also add code to the myMovedMouse function so that we can drag an object. We first search the GQ to find the object the mouse is pointing at. If found, we set the object position to the new mouse position. We also add to myKeyboard function the case P, which duplicates an object that the mouse is pointing at, and case D, that deletes an object. Now let us compile and run this program.
So these are the two functions we have added. P to duplicate an object, D to delete an object. Okay. We use the erase function to erase the object that is found. Okay. The function isTarget is to check whether the object is in the GQ. Okay. Now let's compile and run this program. So we can draw as before the line, the triangle, and rectangle. Now we can also duplicate an object by pressing P. Oh, sorry, I think I compiled the wrong one. It should be in draw free. Okay, draw was the old one. So it should be draw free. Okay, that's the one that I've shown you. So we could draw as before, pressing L, a triangle, pressing T, and we can move this around, drag it, and by pressing P, we duplicate another one. Okay, and we can make further duplication by pressing P. Okay, and move the object around. We can do that to rectangles also. Okay, so we can draw more rectangles. Okay, or we could duplicate this. And we can also delete an object by pressing D. Okay, so we can delete this. Okay. Delete this one. Okay, so this is a simple graphics program using OpenGL to draw different shapes using the polymorphism mechanism. Okay. So this technique, polymorphism, can also be applied to create drivers for different devices. Okay. And so you just need to point to the appropriate driver associated with a device, okay, instead of changing the whole program. So you can add new features to this program and experiment it yourself. Okay. Thank you for watching. Okay, bye.